So again, my name's Andy Rivenes, and we have Maria Colgan, and so we're going to do another database and memory AskTOM Office Hours. So as always, we'll answer your questions. I thought we would do for the focus this time, since we always tend to have a focus, that we do a review of what we talked about in 2018 and kind of go over some of the highlights. I counted up 8 sessions that we did last year. So I thought we'd just briefly chat about them and the points that we tried to make about database and memory on each of those. And then answer any questions you guys might have about database and memory. So I guess with that, we'll go to the next slide, our safe harbor statement. And so I just a reminder with database and memory, I guess we can go to the next slide, that is all about analytics and columnar formatted data, where we have now an in-memory column store that you can enable with an in-memory _ size parameter. And it targets analytic queries, so it's not going to speed up directly inserts, updates, and deletes. And so what we did is we started our very first session talked about configuring. So I guess we can launch into that. So that was back in February, but kind of the highlights is, as I said, there's an in-memory column store, and so it's part of the SGA. So database and memory, couple of things I thought were key highlights to remember about database and memory is that since it's fully integrated into Oracle database, it works within the construct of Oracle database technology. So where would you put data that everybody can access? You put it in the SGA. How would you allocate it? Well, an initialization parameter, in-memory _ size. And it is a static area. We've covered that several times, but when you populate something in memory, it stays in memory. And unless the instance were to go down, or you say alter table no in memory. And one of the really nice things about it is you get to pick and choose the objects that you want to populate. So it's not everything in memory. It's selected tables, partitions, subpartitions, and materialized views. And one of the questions we had is, can you use, and I had this recently again, just popped into my head, can you use huge pages with database and memory? And the answer is, well, if you can use huge pages with Oracle database, then you can use it with database and memory. There are restrictions with automatic memory management and automatic shared memory management, but those don't have anything to do with database and memory. And that's kind of one of the key takeaways, is that database and memory works with all of Oracle technology. And again, you're only limited by Oracle database itself. So I guess we go to the next slide. You do see it. I think I had this here just as the ability to, in SQL Plus or as a DBA, you can manage the database the same. You would see a new in-memory area if you allocated the column store. I think I have, was that 4 gigabytes there? And so it really doesn't change any of the existing administrative features of database and memory. You still have the optimizer, you still have SQL, you still have all of the management issues that you'd have otherwise. And I think it was on the next slide I had, I guess I could look ahead actually. No, let's, I guess, go back for a second. Well, the one thing I did want to point out that has actually come up a few times lately is that basically don't steal memory. So that's kind of one of the big keys to database and memory is typically I'll say that in-memory is an enabler, because it's really the columnar formatted data, and we talked about that in a couple of our follow-on sessions, but that you don't want to, if you have say you had 500 gigabytes to allocate it to your SGA, you want to take a bunch of that memory and put it into the column store, because your other workload is very likely to suffer. And so really the thinking with the in-memory portion of database and memory is you need to add additional memory to the Oracle database, and therefore allocating that to the column store. And that's something I still come across. I don't know, Marie, if you come across that issue, but people still they kind of get it, but yet there is a cost associated with adding additional storage if you needed to your database server.
No, absolutely, right? I think one of the key things people need to remember is because it's not a cache, you do need to have enough space to accommodate all the objects that would benefit from being in the in-memory column store. And that means you're going to need to add a little bit more memory to the Oracle database. Now, that said, every time you upgrade the Oracle database, typically it needs a little bit more CPU and a little bit more memory anyway. So from that perspective, people should be quite used to this, but I don't think they always think about it.
Yeah, exactly. So let's go ahead and go to the next slide. So I think the other thing that we tried to point out in that first session on configuring database in-memory is how simple it really is to do. It's just a marker, an alter table. Actually, you can do it on a create table statement as well, but you can allocate an object to be in memory or no in memory. We support partitions. And one of the things, actually, we'll talk a little bit more about this when we get to one of our later sessions on compression, but you can also restrict, you don't have to have all of your partitions if you have, say, a time series object. So you can say maybe only the most current partitions you want to have in memory. And you can also restrict or exclude columns from database in memory. So if you aren't running analytics on all of the columns, maybe you have some wide tables, maybe you have lobs, you can actually exclude those columns. So that can also not only save you memory, but speed up population, because remember, initially we're only enabling objects for in-memory, and then population based on priority will happen in the background. And so when you start up the database, it doesn't take longer to start up because we're going to populate all of that in the background, like a lot of the other Oracle database processes that will occur in the background. Again, tables, partitions, subpartitions, and then materialized views as well can be populated in the column store. And then I have here, the only thing we don't populate are IoTs and hash clusters, which are typically OLTP type structures, and then out-of-line lobs. Again, lobs, other than perhaps JSON type data types, lobs typically aren't really analytic in nature anyways, and so typically you would probably exclude most lob type data from the column store just to save that space if you have them in line in a table that you would be populating. Some people will actually have separate tables for lobs, and so that isn't actually an issue for them. Anything else you can think of? Nope, guess not. How about, sorry. How about the next slide then? So that kind of covered our configuring. And then we talked about, since we've said, well, it's in memory, but it's not for all data types or all query types, I guess I should say. Analytic queries, why are they so much faster? Why don't I just populate all the data in the row store or cache all the data in the row store versus populating in this in-memory column store? And so what we did is we kind of went through the different technical aspects of database in memory and why the column store is so much faster. So I think we can go to the next slide. And we talked about, and this is something we do in our normal sessions as well, and it's in the technical white paper where we talked about the fact that with columnar formatted data, we only need to access the columns that are part of the query. We don't need to read over all of the data in each of the rows to get to the columns we're interested in. You can compress that data. Since it is columnar, it compresses fairly well. Most columns will get anywhere from a 2x to a 20x compression rate, or at least the object will. The columns will get varying levels of compression. In-memory storage indexes. So we're able to skip over data or prune out data that we don't need to access within something we call IMCUs, or in-memory compression units. And then we reviewed SIMD vector processing, the ability to access multiple values in essentially one instruction cycle. And this gives us the ability to go from scanning millions of rows per second per core to billions of rows per second per core. And let's see, how about the next slide? Because in addition to the technology, we had talked about some of the optimizer enhancements. So when you've enabled objects for in-memory, the optimizer is aware of that. And so it will actually do compute some statistics at hard parse time of the query and use that as input to the execution plan. And so we can basically, the optimizer can decide to push filter predicates into the scan of the data rather than applying those filter predicates on the resulting rows that come back. In addition, we can not only just filter predicates, but what I call function-based aggregations, or mins, maxes, averages, can all be done during the scan. I like to tell folks that the best database in-memory query you can have is one that can do all of the work of the query during the scan of the data and return back just the results of the scan of that particular object. In addition to that, joins, and we had a session on joins and aggregation, but we can turn hash joins into scan and filter operations, and we can turn group bys or aggregation group bys into not only a scan and filter operation, but an aggregation in memory as well. And we did a couple of sessions on those, so I won't spend a lot of time on that. But back to my point about caching data in the columns or in the buffer cache as opposed to populating the column store, I had a, let's go to the next slide. I had a nice little graphic that I use that shows something I do on, we do in the hands-on lab and I do in a in-memory by example, but it shows literally the same line order table fully cached in the buffer cache and fully populated in the column store, the exact same query, and we see that it runs in a hundredth of a second in the column store and takes over 8 seconds in the buffer cache or in the row store. So, and that's with no I/O. That means all of it was cached in the buffer cache. So when people say, well, if I just put everything in the buffer cache, wouldn't it be just as fast? And the answer is, well, all those things that we talked about for technology and the optimizer enhancements make it so that it really is an order of magnitude or more. We typically say 10x to 100x performance improvement, and it can be very significant, and that's kind of the magic behind database in memory.
Andy, one quick question for you on that. You're talking in this example about the entire table being populated into the in-memory column store, but what happens if I can't fit my entire table and maybe only some of it is there and some of it is still on disk?
Right. So what Oracle can do or will do is it will, and that can happen both running out of memory or even at startup when population hasn't completed yet, or maybe data has been added to the the table, maybe a bulk load, and that data hasn't been populated in the column store yet, or data has been changed. And I think we talked about a couple of those issues later on in some of our sessions. Bottom line is that we'll scan the data that is in the column store, and data that isn't in the column store we'll get from the row store. So while the performance won't be as fast as if all of the data was populated, the application won't get an error. It will return all of the data. It'll be read consistent because we preserve the Oracle transaction processing mechanisms and architecture. So we take an SCN, we know we have read consistent view whether it's in the row store or the column store. And so your application won't see any errors. Is that what you wanted me to say?
That you've just told me about for the data that is scanned from the in-memory column store, it's just the data that's coming from the row store may not be as fast to access because it won't have all those optimizations, right?
Correct, right.
Okay.
So we can go to the next slide, I guess. So then we focused on hash joins. So of the the optimizer enhancements, I kind of singled out hash joins. One of the reasons that it occurred to me as I was on my tour of different user groups last year. Typically, the beginning of the year is our heavy period of user groups, and people were, some people had questions about hash joins, and so I figured, well, why not cover hash joins in detail since it is a very significant part of Oracle database and memory and the speed up there. So, so we did a session on hash joins, and I got a little deep on things, but I basically kind of went through the characteristics of a hash join and actually how it works within Oracle database. So we did a diagram. I don't know, did I include that in? Oh yeah, I did. So I won't, yeah, there we go. So we kind of talked about how typically a hash join will join a smaller table to a larger table, and we'll build a in-memory hash table in the PGA, and then we'll probe the larger, so the smaller table, we'll scan it, we'll build a hash table in the PGA, and then we'll join that to the larger table, and we'll probe that hash table to see if we have a match. And we'll pick up my little drawing or diagram there shows not only that, oh, I can't point to it, but I guess you could, but the the hash table itself, and then we also carry along the columns or the payload columns that are part of the join, so that we don't have to go revisit the smaller table and double dip. And so what we do is we probe, when we have a match, we can pull what we call the payload columns along with any other matching columns from the larger table and return those as part of the join. And I think that's kind of the 10-second summary of how that hash join works. And then what we did is we pointed out how database in memory does a hash join. So that'll be the next slide. And the fact that we are able to scan our storage table, and based on the matching store IDs, after we apply our filter predicate, we have our join key, and we are able then to scan the sales table. And the magic behind that is in our next diagram, in the ability that we actually use Bloom filters. And so Bloom filters been around in Oracle database since 10G, but we apply a Bloom filter, and we kind of went through the fact that it's a bit vector. And what happens is that for each of the filter predicates, functions applied, and if the value is there, we put a 1. The value is not found, it's a 0. And it's a fairly large structure that then gets folded together, but winds up being a fairly dense memory structure that we can then apply to the, let's see, so I must not have turned animation off on that. So it looks like we have multiple, if you hit enter, is it, there we go. So, okay. I typically will do the whole slide and then do multiple pictures of it so that when you look at it in a presentation or PDF file, it all shows up. But so we basically scan the storage table. We still create our hash table, but we also create a Bloom filter. Then we apply that Bloom filter, and this is the being able to change a hash join into a scan and filter operation. We're able to push those Bloom filters, or essentially those filter predicates, into the scan of the sales table, and then actually return just the rows that match back to the calling query. But in the meantime, we still have to pick up those payload columns, and so that hash table still has those payload columns. And so we're essentially able to do the join, the scan and filter of both tables, and then just pick up our resulting column values that we need to then return to the join or to the calling, to the row source. And so that can basically be like a 10x performance improvement. So a little bit different scenario. And if I confused you, you can go through and look at our session that took about an hour to go through, and with a lot more details. But that's kind of what we covered, and what I'm trying to highlight now is just the magic or the technology that's part of database in memory. Did I get the point across, Maria, or is that too much, too fast?
No, I mean, it was a lot, but I think for folks who are familiar with hash joins and how they work with the Oracle database, I think the secret sauce or the magic here, of course, is the creation of that Bloom filter and pushing it down to the scan of the sales table in this example, because what it'll do is it'll basically reduce the number of rows coming out of that sales table and going into the hash join. So speeding up the join process there by basically not returning any rows that won't match, because we've already filtered those out as part of the scan, using all the optimizations that you've talked about, like applying it using the vector processing, by using the storage indexes. All of that are helped with that bit vector. So it's a very efficient way to do a join between two tables for sure.
Cool. So then we're actually ripping through this pretty fast. I guess if you do have questions, don't feel free to join in. Yeah, so wanted to make sure we highlighted. I think that's all the points I wanted to make, and I may remember some. But in addition to that, in 12.2, and that's kind of one of the other takeaways we've talked about in various times, is that as we've improved database memory, we've actually added features to make the optimization and the running of queries even faster. And I talked about this to a couple of customers very recently. Once you're populated in the column store and once you're running an in-memory query, and I'll repeat, I tell people that typically what you want to see is essentially all of the processing time associated with scanning and filtering and joining and aggregating the data in the column store, that we're really just bottlenecked on CPU and memory at that point. And so what we've done is basically added what we call high performance type options, one of which is a join group, to basically make that CPU code or that code path within Oracle and even faster to reduce CPU time. And so if you're only running on CPU and accessing memory, then the only way to speed that up is basically to make your CPU footprint smaller, reduce the amount of CPU you're consuming as part of the query, or parallelize. And we'll talk about parallelize in a little bit. But and so join groups are one of the things we added in 12.2 to make hash joins even faster by pre-computing or basically identifying to the Oracle database. Whoops, we lost her, but I'll keep going. To identify the Oracle database commonly joined columns. And so by creating a join group, then we're able to tell the database, or we're able to essentially materialize the hashing that goes on between commonly joined columns. And so a join group can save a significant amount of CPU time spent joining multiple columns or multiple tables that we know are commonly joined together. And so that's essentially what a join group does. It saves on decompression of the data, but really saves on hashing of the data, because now we don't have to hash it. We've pre-hashed that data, if you will, to make that hash join go even faster. And this is even perhaps more important. It works with when we do have Bloom filters and we have a filter predicate, but it can really make significant improvements when we don't have a filter predicate, when we only have just the join keys, but no selection within, like, say, the vehicles table here to allow us to create a Bloom filter, which I guess I didn't mention, but to create a Bloom filter, you have to have a filter predicate. Because if without a filter predicate, you don't get a Bloom filter. And so join groups are another way of improving that, because not always are you able to filter on your smaller table or your dimension table. Sometimes you're actually joining all of those columns or all of those values together and feeding that to another part of the query. So we got through the the navigation there. Did you have anything to add?
First of all, apologies for that. But second of all, what I wanted to just mention is, because you said it there, that you don't get the Bloom filter unless you've got that filter predicate on the smaller table. And the reason for that is that the whole point of building that Bloom filter is because we've got a small number of values from the left-hand side of the join to help filter out rows from the right-hand side of the join. If we don't have the filter predicate, then effectively all of the rows from the vehicles table would have to be used in creating that Bloom, the Bloom filter, or that bit vector that we would send down as part of that hash join. And so it's really just the overhead of having to build that Bloom filter. If you've got to put every row from the table on the left-hand side in, is the reason why we don't do it. Because technically you could do it, it just doesn't make sense from time and cost.
Yeah, exactly. Yep, a good point. And let's see, where are we at here? So that would be the end of the focus on hash joins session that we did. Hopefully, kind of the takeaways there are that database in-memory does optimize a hash join, typically with filter predicates. You get on the dimension tables, you can get Bloom filters, and we can do we can return far less rows to the hash join itself than without that. Even though when we can't or we don't have a filter predicate, with join groups on commonly joined columns, we can still significantly speed up a hash join. And it's still going to be faster even without either, because we're able to scan that data in the column store, use in-memory storage indexes where we can skip over IMCUs, and of course we have the SIMD vector processing that allows us to scan orders of magnitude faster than we can in the row store.
So it looks like we might have a question, Andy. So let me just have a quick look in the chat. So I don't know whether you can see that on the screen.
Yeah, since you're running the slides, I'm able to put that up. So we have a question about the type of in-memory compression. Yeah. What method do you suggest? Tell you what, can we hold that question to, because we actually did a whole session. It's in two or three slides, but we did a whole session on compression. So I will go through that for you in specifically to answer what level of compression might make sense. And then I have another question that just came in. Whoops, now they're coming so fast. I can't keep up. So are we referencing 18C? Actually, yes, but database in-memory was introduced in 12.102. And in 12.2, we added things like hash joins and in-memory expressions. And in 18C, we added further enhancements like in-memory dynamic scans. But we're actually, for the most part, unless I call out a specific feature, it covers all of database in-memory. So all the way from 12.102 up through 18C. So it's not 18C specific. And nothing we've discussed so far is 18C specific, although we have enhanced quite a bit of the predicate pushdowns and some of the scanning abilities in 18C, but nothing that would preclude you from doing any of this with 12.1 or 12.2. And then there was another question that went by.
So are there customer use cases of using in-memory featured in a sharded database?
I'm looking for the use case of Oracle JSON support, storing all customer data in a JSON in an Oracle sharded database. I'm aware SOTA application or collections are not available in sharded database. Database interested in 18C. So we do support database in-memory on sharded databases, and we do support JSON data populated in the column store. I don't know of any specific customer use cases for using, I assume really the question is JSON data stored across sharded databases with a key that you could then determine which shard to scan for that data. Do you know of any, Maria?
Yeah, I mean, you can certainly do it as long as you've got the key. As Andy said, the benefit of sharding is that the application is shard aware and it supplies the shard key or the partitioning key that's been used to distribute the data across the shards. As long as you've got that, there's no reason why you couldn't use this combination. We can put the JSON document into memory, and you can partition on a JSON document or on a field within a JSON document. That is possible. So it's all possible, but do I know of any, are there customer use cases of that? I'm not familiar with anybody who's doing that today.
Yeah,
but there are a lot of people and some well-known companies that are using JSON in the in-memory column store today.
Yeah, I think that we are going to do, so we did in-memory expressions at the end of 2018. That was our last session we'll talk about. And then that kind of flows into talking about JSON. I think one of the keys probably would be that you wouldn't, in order to get the sharding to work, you would probably then take one of the functions and just populate. So with JSON, not only can you populate the entire document in JSON in a special binary format in the column store. But you can also apply functions to just populate certain portions of a document. And so that would probably be what you would put your shard key on as far as JSON. So while it's all doable, I don't, that's pretty new stuff. So I don't know anybody who's actually done it yet, but it's certainly all doable, as Maria said.
All right, that seems to be it for questions. So
and we're going to table our compression question. I think we caught the other one. So yeah, and feel free to keep sending questions in, because ultimately that's why we're here, is to answer those kind of questions.
all right.
And then we talked about aggregation. And what I mean by aggregation is we have a feature in memory aggregation. There is actually a white paper that talks about all of the gory details of in-memory aggregation. And what you'll see in an execution plan, once you have in-memory enabled, so in-memory underscore size is enabled, not only in in-memory queries, but in non-in-memory queries as well, or maybe even in exited smart scans, you'll see an operation called vector group by. And so that's kind of the implementation of what we call in-memory aggregation. And so let's go to the next slide. So I kind of went through the different types of group bys, and what we're really talking about is being able to do a group by and the aggregation portion of the group by in addition to the join, if there is a join. And we actually support in 18C now single column group bys as well. That just gets pushed down into the scan. I hope I got that right. There's so many features, sometimes I get those mixed up. But if it's not, I think it's available in 18C. Maybe that's the 19C one. Maybe you're going to get a teaser. But it actually just shows up as part of the execution plan, the notes section. So I'll have to I'll either blog about that or talk about that if that's 18C. I don't know how else to get that information, but if not, that's in the plans. But bottom line is that the sort group by and hash group bys are currently available, and then in-memory aggregation with database in memory adds vector group by. So let's go to the next, because I think we did a little diagram. Yep. Actually, I think you originally created this, Maria, as I assume you created it. I don't know who actually did it, but it basically is a nice way of identifying how in-memory aggregation works, in the sense that we have our hash joins, and in this case, think a star query. We have two smaller dimension type tables, products and stores. We join that to a sales table, and we have, in addition to that, a group by. And so we do the same basic hash join mechanism we did before, except now we use key vectors rather than Bloom filters. And we do that so that we don't, so we know all of the values that'll be accumulated or as part of our, what I would call in-memory report accumulator. Essentially, think of it as a or in this case, two-dimension, but a multi-dimensional spreadsheet where as we do the scan of the sales table joining the products and stores tables, this time with key vectors rather than Bloom filters, but doing that applying those filters along with any other filter predicates. As we do that scan of the sales table, we can actually do the aggregation at the same time, and then what the in-memory report accumulator does, or that aggregate accumulator pictured there, is actually allows us to do the aggregation during the scan. So by the time we're done with the scan, not only have we done excuse me, the joins, but we've done the group by as well, or the aggregation. And we can return all of that to the invoking query, or the bring that row source up into the other parts of the SQL query. So what this does is it allows us to do, again, all of the work of that query or that SQL statement in the scan and filtering of the data. And so then that's kind of the goal. If you look at a SQL Monitor report, what we're looking for is to see all of the time spent in in processing the in-memory objects in the database. Anything to add there?
No, I think you covered it all. Just so people are familiar, I don't think we've got an example in the slides of the execution plan, but all of the steps that you've just talked about building the accumulator and then passing the information back to the end user, all of that is visible in the execution plan. You'll be able to identify it by looking for vector group by as the keyword in that plan, as opposed to a sort or a hash group by.
Right, and in the session we had, we went through. I mean, this might have been our. I don't remember. This was either the hash join or this one was our longest session, and we went through an example and showed the execution plan and the vector group by and the key vectors and how again they get applied to the in this case the sales table, and went through all of that in great detail. So if you again find that interesting, there is an in-memory aggregation white paper, and then you can go look at the Ask Tom session we did for, and actually we did some examples running queries and showing the parts of it and how they worked. So.
And we also have like shorter videos. If you don't want to sit through a 45 or an hour-long Ask Tom session, if you go to the Database in Memory YouTube channel, right, you can see the shorter snippets from those casts as well.
Yes, that's true. So you can see just the demo part of it. And actually, one of the slides I have at the very end, I'll highlight again all the places that we have for you to be able to go see database and memory information. And the YouTube channel is actually is definitely one of those. So let's continue on where I think we talked next about RAC. Right, so database and memory, since it works with all Oracle functionality, it works with RAC as well, and that's kind of our scale out option in the sense that since we are talking in memory, you are allocating the column store as part of the SGA, a single server can only have so much memory. And so the way to expand the size of the column store then is one way is to be able to add RAC to the mix, and you can have a column store on each of your rack nodes in your cluster. And so since we don't share data, although on Exadata you can duplicate data, but for all intents and purposes, the scale out is that we don't populate the same data on each column store. We distribute the data so that we have data across all, in this case, 4 nodes. And so now if you had, say, 100 gigabytes of column store on one node, you might have 400 gigabytes of column store across all 4 nodes. Or more realistically, maybe a terabyte on one node, and you could have 4 terabytes of data across all 4 column stores. And then we talked about the ability that the IMCUs aren't shipped across the interconnect. So kind of, I probably should have just highlighted that last statement, is that we use parallel query to access the data across all 4 nodes. So that implies being able to have at least one parallel server process on each node. This is now not 18C, but so for 12.102, we required that you have AutoDop enabled so that we knew which nodes we had to fire up a parallel server process on. Oh, yeah, I guess I have it right there. And in 12.2, we relaxed that restriction to where if you want to have a manual DOP or a DOP of greater than, or at least as great as the number of nodes, in this case a DOP of 4, but you didn't want to use AutoDop, we allow you to do that as well. In 12.102, that wasn't the case. In 12.2, 18C, all you have to ensure is that you have a DOP at least as great as the number of column stores. In general, though, AutoDop isn't a bad thing to use because it does allow the optimizer then to come up with an optimal parallelization plan. However, as I tell a lot of when I do sessions, that sometimes parallel is a 4-letter word to a lot of DBAs, because let's face it, if you're in a mixed workload environment, not necessarily data warehouse environment, but mixed workload where you have OLTP access, just allowing parallelization to go across all of the CPUs that you have can affect OLTP access. And so somehow you have to come up with a way to split that up. One of the ways is services, which we did talk about, and services can also be used in support of, I think we had that in the next, did I have that in the next slide? Oh, did you? Oh, maybe that was in the services. So we actually did a follow-on with services. So let's go back. Let me make sure I got all the points I wanted to in the rack part before I jump into services. But I think the takeaways there were that we don't distribute, or we don't ship IMCUs across the interconnect. So we do require parallel query. In 12.1, we require AutoDOP. You can use AutoDOP in 12.2 or 18C, or you can just ensure that you have a DOP that's as great as the number of nodes.
So,
And then the only other thing I think to mention is that if you do have an engineered system, you can take advantage of duplicate, an option to the alter table command for distribution, where you can actually mirror IMCUs across different nodes, so that if one node were to go down, you'd still have all of the data in one of the other column stores. If that occurs without duplicate or on like a commodity server, then the portion of memory that's in the column store for that node would be unavailable, and we'd have to go to the row store to pick up that data. And then there's some other details I won't try to go into.
two quick questions, Andy,
Yes.
just on that to make sure that we give them the complete picture on rack. One, does the in-memory column store need to be the same size on all of the rack nodes?
It doesn't, but depending on the distribution that you're using, in general, we're only going to use, the goal for distribution and using multiple column stores in rack is to have a fairly even distribution of data, because you don't want one of the parallel server processes to finish, or maybe say 3 of them finish and one of them is churning away on twice as much data, because then that gates your performance for that particular query. So the idea is that we want as even distribution of data as possible. I think when we get into services, you can get around that by having subsets of column stores available for different applications or different uses. But in general, we want them to be even, because most of our distribution algorithms expect to evenly distribute across all 4 column stores.
Okay, and then the other one is, before we get into services, is there any way that I can limit which rack nodes the in-memory column store is available on? So other than using services?
Well, you can certainly not enable the in-memory size parameter on the instances you don't want to have a column store allocated to. Is that what you're referring to?
Yeah, that's what I was.
Trying to make sure I'm on the same page. Yeah, so yeah, you don't have to enable a column store on all of the nodes. Say, for instance, your rack cluster, you might want only a certain number of nodes to have the column store and be available for analytic queries. So you just wouldn't allocate a column store on the other nodes, for instance.
Just a quick reminder to the participants, can you make sure that you are on mute? Normally I do it for you, but since I'm sharing my screen this time, I'm not going to. But with that, Andy, let's move on.
Okay. We're actually chewing up a lot of time here, which is good, but well, I'll speed up a little to make sure we get through everything, because I really do want to make sure we covered all of the sessions. We did a lot of them. So focused on services. What we really wanted to get across with services was in 12.2, we added a distribute for service clause. And what that allowed us to do, whereas in 12.1, you kind of had to play around with services to enable different applications and population to occur when you wanted to have a subset of nodes. But in 12.2, we actually created the distribute for service clause to support active data guard. So now in 12.2, we support active data guard, and you can identify objects you want to populate either on both the production or the primary and standby, or just the primary or just the standby. And so we allow you to do that basically by identifying an object to be populated based on a service, and wherever that service is running, then that's where the object will be populated. And then the side effect of that, though, was in the next slide, was to allow you to run much easier ability to run a subset of nodes for column column stores, or to have application affinity to one or more column stores. And this helps in there are a lot of applications, EBS being one of them, that don't allow inter-instance parallelism. In other words, you can use parallel query, but you have to stay within the node that you're running on. And so by being able to identify objects to populate based on service makes it much simpler to accommodate that. It is possible to do that without this clause in 12.1. We did a 4-part rack series on the blog, but it's kind of complicated and has some limitations. It makes it much simpler with the for service clause in 12.2 and above. And I think that's good. That's everything. So yeah, let's talk about in-memory compression and the different compression levels. So we had a question about that. We have memcompress for query, memcompress for DML, memcompress for query low and high, and memcompress for capacity low and high. And I did a blog post, and actually we centered the AskTOM session kind of around that blog post. And what most people will think of, so the default memcompress for query low is kind of the best all-around compression level for database and memory. Typically, customers will see anywhere from usually you see at least a 2x compression level with the default. Sometimes it's 4x or higher. But usually when you say compression, people kind of roll their eyes and think, well, gee, if I use compression, I'm going to have to decompress that data, so it's going to cost me. So I don't want to do any compression. I don't have to. You kind of think of like zip type compressions where there's a lot of overhead. And with database and memory, memcompress for query low and memcompress for query high, we actually operate directly on the compressed data. So we're doing symbol replacement or dictionary level encoding. And with query high, we do more aggressive run length encoding to do the compression. And so that's kind of what this was centered around. So if I'll go back at this point to that question that was asked about what do we recommend or suggest for compression on a data warehouse. So basically, with compression, and this is true with the on-disk compression that we offer as well, is that your mileage will vary based on your data. And so you really do have to experiment with the different levels of compression. Especially in data warehousing, very often memcompress for query high will give you better performance and significantly better compression than the default memcompress for query low. But it depends, because we have customers who say, no, memcompress for query high doesn't work for us, it's slower, and we don't get enough compression benefit for the trade-off. And that's kind of, so the answer to your question is, yes, try both of them, see which one benefits you, and it may be data dependent. So not all objects, you may not be able to do all objects at the same level. You may have certain objects that benefit from higher levels of compression and other objects that don't. And so there is a compression advisor where you can test out the amount of compression you'll get from different levels, but it won't tell you the performance. And so that you kind of have to benchmark on your own. But back to the higher compression levels, for query high, and then memcompress for capacity low, capacity high actually add a zip-like compression on top. And so my point of the session and the slide was to say that if you're memory constrained, sometimes the trade-off in performance, which isn't that significant in many cases, versus the amount of memory that you can free up or the number of objects that you can populate, which can be very significant, can be worth the trade-off. So just because you say experience a 20 or 30% degradation in performance or response time performance, but you're gaining 2 or 3x in capacity for the column store, that trade-off versus not having those objects populating the column store at all, where we're talking 10x performance improvements, can be significant enough to warrant actually experimenting and making use of the higher compression levels. So what do you think? Did I cover everything there?
Yeah, I think you hit on pretty much all of the things we say about compression and about that trade-off. But for most people, at least in my experience, the default query low has been pretty successful. How about you, Andy? Did you
Yeah,
see?
no, in general, especially in mixed workload environments, that tends to be definitely the case. The warehousing environments, I think, you have a little more flexibility because you are able typically to take advantage of parallelism. And if you're one of the other examples we had was if you're able then to filter down the data so that you're only literally accessing parts of the data you're returning, the difference in higher levels of compression on response time could be considerably less. So again, a lot of this came about in my mind was with people who are saying, yeah, I don't have enough memory to populate all of the objects in the column store. And so does it make sense for me to still use database and memory? And kind of my response was, well, have you considered higher levels of compression where you can gain significant capacity or the number of objects you can populate and not really experience that much degradation, and certainly not as much as if you didn't populate it at all in the column store. So let's move on to the next one. We are starting to squeeze a little on time. And I think I threw in a slide here to show the performance difference and that you don't see any difference in the actual execution plan. I think that's why I threw that in there. I kind of tried to go through and throw out the slides that highlighted the points we wanted to make in the different sessions. And the last one we did, session we did was InMemory Expressions, another 12.2 feature. It's surprising how many expressions, commonly executed expressions, arithmetic in general, arithmetic expressions are executed and that are common across either all the rows or classes of queries. And I think the main point here was that although we do have both a dynamic ability with the optimizer to automatically populate expressions, or you can identify those expressions manually. We do populate those in the column store. But back to my point about CPU and memory access and trying to save CPU cycles, well, you can save significant CPU cycles because it is actually quite surprising that once you're running an in-memory query, some of these arithmetic expressions can take quite a bit of CPU. So you can significantly improve your performance. And the line I usually use is I have a good friend who likes to say that the fastest way to do something is to not do it at all. And I kind of add, well, the next fastest way to do something is to only do it once. And that's really the takeaway on in-memory expressions is why keep re-executing the same expressions over and over again for multiple queries. And maybe the queries are the same query, or maybe they're slightly different when you can do that and pre-populate those in the column store and take advantage of that expression already being calculated. So I think that was what we had there. And
I do like that. I'm going to steal your, if you have to do it, only do it once. But
yeah, feel free. But I think it gets the point across. I think people can understand that kind of like sometimes we talk about materialized views, and it's kind of like a materialized view, whereas we're instead of materializing the entire query, we're just materializing the expression.
right.
And so I did want to, I'm amazed that that took all that time to go through. But, well, we did talk about like 8 sessions is a lot of sessions. But I did put together what I thought was the key areas where you can get more information. Obviously, you can go back and look at our entire Ask Tom sessions or with dialogue, or as Maria pointed out, you can look at just the Ask Tom YouTube channel, the 2 at the bottom there, the Office Hours URL, which is actually on the page that you navigated to get to this session here. But also on our YouTube channel, I've tried to chop up the sessions into just the demonstration. So you can see in SQL Plus how all of this works and get the abbreviated version of it without having to go through the entire session. But I did want to point out our blog where we do talk about a lot of this. For instance, the compression session was inspired by that blog post. And then our resources page, which is slightly hidden, and I will bring that up again just so people understand. Whoops. It was funny. I had the time up because my Mac time was off from my regular time for some reason. It was like 5 minutes faster. But oh, you can't see this. Sorry. Oh well. So in the, I guess in the blog, my only point was that resources page is up at the far right corner. You have to navigate where there's little menu bars. If you click on that, there's a resources page, and that resources page I've put almost all or most of the important, like the white papers, the YouTube channel, our OTN page where we have customer, oh yeah, there you go, you got it there. Our customer information. I try to make that kind of what I call our portal into database and memory. So if you ever get stuck, you can go to that resources page. Notice how it's on that menu. So it's kind of, it's not as obvious. Unfortunately, we're constrained by the blog requirements of Oracle's blog group. And so, but that resources page has lots of information on there. Actually, I even recently put, I had a bunch of SQL Monitor questions. So Maria has an excellent SQL Monitor discussion or tutorial, if you will, on her SQL Maria page. So I stuck that on there as well, since we do use SQL Monitor a lot to, people ask, well, how do I know that I took advantage of database and memory? SQL Monitor reports are an excellent way because they're time-based. And so they can show you where time was spent during the, I think it's next one down, the section, where did I put it? It's with the technical briefs, so go down even further. There, I put it, I said technical briefs and other links, and I stuck SQL Maria, getting the most out of SQL Monitor. And so that's actually worth a view because, as I said, I think SQL, or Maria does the same thing I do, is that show me a SQL Monitor report and let's evaluate, did database and memory provide you with performance? Not only is it wall clock time, but can we show how database and memory provided you with the additional speed up? And in a SQL Monitor report, since it's time-based and shows you the execution plan of the different operations, you can actually see very easily whether database and memory benefited you and how it did. So kind of my my plug for the SQL Monitor as well.
Cool. Well, I thank you for the shout out. But one last thing we should remind folks about is that on that Ask Tom page where they registered for this event, they have the opportunity to ask questions. And if there's a particular topic they'd like to see us address in an office hours, you can always submit the question there and we'll be able to address it in an upcoming office hour for you.
Absolutely, yeah, that would be great because we're always trying to think of topics, and a lot of the topics I choose are based on customers and who I talk to, and so if you definitely have a request, let us know. We're more than happy to do that. We'll take one of your questions, and I think I'll pencil in a JSON session. Again, kind of follows up on InMemory, and maybe we can elaborate a little bit more on JSON usage with database and memory. So, but yeah, definitely. And thank you all for participating, the questions that you asked. Hopefully this was of use, and I guess we'll see you probably next month. You have anything else, Maria?
No, that's it from me. Thanks, Andy.
All right, thank you. Talk to you all later.